Last, we looked at if else. If statement, then inside if statement, we look at if else. Now, if else allows us to do one of two things, either this or that. That means I can have a variable like this. A is 1. If A is equal to 1, then print hello. Else print ooh. So it's if A is 1, it's going to print hello. Right? But if A is any other thing aside 1, it's going to print ooh. Do you get it, sir?
Yes.
No, but there are some situations whereby you want to do different things based on different circumstances. For instance, maybe if A is 1, you want to do something. If A is 2, you want to do another thing. If A is 3, you want to do another thing. Do you get it, sir?
Yes.
So not just one of two. This is one of two. If A is 1, do something. But if it's any other thing aside 1, then do print ooh. But like I said, there are some circumstances whereby you want to do something different things based on different conditions. If A is 1, do something for me. If A is another thing, do something. If A is still another thing, do another thing again. So that is where L if comes in. L if. Now notice something. If A is 1, there's a condition here. If this condition is met, it will do this. But there is no condition in the else. That means we only have this condition to check. If this condition is not met, just jump to the else. But in L if, there will be another condition. So let's do that together. I will remove this now and replace it with L if. L if. We put another condition here. Print, let's say, great. So if A is 1, it will print hello. But if A is not 1, it will check if A is 2. If A is 2, it will print great. Do you understand, sir?
Yes.
So when we run this now, this is going to print hello. But if A were to be 2, this is going to print great. But if A were to be 4, it's not going to do any of them because it does not meet any of the two conditions. The difference between L if and else is that L if we have a condition, else does not. Else means as long as the first condition is not met, do the else. But the L if the first condition is not met, it will check the second one. And the L if can be as long as you want it to be. So if A is 4 now, it's going to print bad. Any questions so far, sir?
Yes.
Now, we can also end an L if with a final else. This is like the if else. Maybe nothing to say. So if none of these conditions now from beginning to this part, if none of them is met, then it will do this for us. Do you get it, sir?
Yes.
Okay. So let's assume A is 20. It's going to print nothing to say because it does not meet any of them. Now let's move forward. Let's look at a scenario. Let's say A is greater than 10. A is less than 50. A is equal to 20. Now let's look at this scenario. Which of them do you think it will do? Or what do you think it will do? I don't put like that. What do you think it will do?
Okay. If so 1. A is 9 equals to 1. So A is equals to 20. Print great. So it's going to print great.
Okay, perfect. Perfect. So, now you know this condition is also met because 20 is greater than 10. And
But it is at the first one.
exactly, it will stop at the first one. You get it right. So the way it works is that in elif, as long as the first one is met,
Do not go for the other.
you should not check the rest. Do not check the rest. Now let's look at another scenario. Now, in this case, it's going to print great and it will also print money. Being that this A, everything here is one block, and if block starts with if, and if block starts with if. So this is if here. This is going to see all of this as one block, and this is another block. So inside this first block, it can only do one thing. Inside the second block also, if this condition is met, it will print money. Do you get it, sir?
Yes.
So when we run this now, we see great and money. Great, money. Now, we want to move to what's it called? The logical operators. Logical operators. There are three logical operators that we want to consider. We have the nuts, we have the or, we have the and. Nuts, or, and. Let's look at the first one, nuts. The nut is used to negate something, opposite of something. So if I have a variable, I can say if A is not equal to so which is it going to print? Is it going to print hello or hi?
Hi.
Good. Thank you, sir. If A is not equal to 4, print hello, else print I. So this is going to print I since A is 4.
So this is the sign for not.
Yes, sir. Yes. This is sign for not.
Like, is there space between A and that sign?
Yes, sir. Although, even if there is no space, it will still work. The end of the space is to make it readable, not so that it's not going to be choked together. That's the end of the space here. Also, that's the end of the space here. But this not equal to will be written together. There will be no space between the nuts and the equal sign. But for others, for the space here, we can write it like this. But it's going to look choked up.
This is exclamation mark, right?
Yes, sir. This is not equals to. If A is not equals to 4, print error, else print I. Now, let's look at the other two. But this not, depending on the data type we are dealing with, let's look at another data type before we leave this part. A can be 2, right? If you say if A is not equals to 2, okay, let's put this one. If A is not equals to 2, print hello, else print I. Now, this can be written another way, and let's I'm looking at. Okay, let's look at that part first. Before we proceed, I want to go back to where we started from. Simple if statements. You see, the way if statement works is that if I say if, then I'll put a condition here. If the condition is met, it will do whatever I have here. Do this. If the condition is not met, it will not do this. That's where we started from. If we put a condition here, the condition is met, it's to do this, right? Alison?
Yes.
Alright.
Yes.
Thank you, sir. Now, but you see, whenever we put any condition here, Python at the end of the day ends up converting that condition to either true or false. In fact, what Python expects here is a boolean. What Python expects inside this place is a boolean. So whatever we write there, Python will end up converting it to a boolean, either true or false. If it is true, then it will do this. For instance, let's say we have something that looks like this: a equals to 2, and we come here to say if a is maybe lesser than 6. So what Python will do is that it's going to check this and say that is a lesser than 6. So Python will internally now, the way it sounds at the background is that Python will remove this and it will replace it with true. Do you get, sir?
Yes.
Okay, sir. So what Python actually wants there is a boolean, such that whatever expression we write there, no matter how long it is, it ends up being converted to either true or false. If it is true, it will do this. If it is false, it will go to the else. But if there is no else, that means it will do nothing. Now, having explained that now, let's now continue. So that means I can just come here. Okay, I can just, in fact, I can remove this and just run this, and it's going to print do this. Do you understand, sir? And if I put false here, it's not going to do this part. If there's an else, it will do the else. Let's run it together. We have this. If this were to be true, it will print do this. Do this. Okay. So we can now do something like this. A is true. Then we come here and say if A. Do you understand, sir? That is like saying if true. Since A is true, that's the same as saying if true. And of course, it's going to print do this. If A were to be false, and we come here to say if A, that is if false, it will print I. Any questions, sir?
But if false, print this. But A is false, so it's supposed to print do this.
No, sir. This is different from saying if A is false. If A is false, it will print do this. Of course, this is going to print do this because A is false. And it is saying if A is false. But what this here means is that if A, this is just like saying if false. Since A is false, it will just take A and put it there. Do you get it, sir?
Okay.
It will just
Now
take it.
let's remove A equals 4.
Okay.
Now, here, if true,
Yes.
true, print do this. But the question is, what is if true? What is true? There's no condition that precedes if true. So there's nothing we are talking about.
Okay, sir.
Do you understand what I'm trying to say?
Yes, sir.
If true, what?
Okay.
What is it that is true that you are saying you are doing do this? You understand what I'm trying to say is, I think this true should refer to something. What is it that is true?
Okay, sir. I think you are looking at it from English perspective. Well, like I said, in fact, all Python wants here is just boolean.
Yes.
All those if A equals to this, if B equals to this that we write here, Python does not really deal with them, because at the end of the day, Python needs to end up converting them to either true or false. So if it's unable to convert anyone to any of those two, it's going to throw an error. So all it wants here is just true or false. If it sees true, it will do this part. If it sees false, it will do this part. Do you get it, sir? So when we have here like they say it's false, and we just say if, it is like saying if false, it will do this part. Any questions, sir? Now we can now do something like this. A is false. We can now say if not A. If not A. Not false. Not false is true. In this case, not false is true. Not true is false. So not A. So it's going to print to this.
But this time, you didn't write not A in A with exclamation or something like that.
In fact, that is reason I introduced this. So as to explain that not is not always exclamation mark. Whenever we are dealing with boolean, not will just be NOT. If you just want to use it to negate a boolean, you are dealing with a boolean, you just say NOT. But if it's not a boolean, if it's a string, then we can use the exclamation mark. Do you get it, sir?
Yes.
Now, if A is true, now not A, that is not so, that is false. That means this is going to point high. So I think for now, we are done with not. It remains true.
This not,
Yes, sir.
not, NOT, can it be used for, I know it can be used for boolean now.
Yes, sir.
What about other
Data types.
data types?
No, it's not going to work. It's a try and error.
So we can only use exclamation for others.
Yes, sir. We can say that. Let's play with this part. Enter your name. Enter your name. So we want to say that if the name entered is Taye, say I know you. If it's not Taye, if it's any other thing, say I don't know you. If name is equal to Taye, right? Else. Now this expression can be written another way. This same thing. We can write it like this. If name is not equal to Taye. This can be in parentheses or not. This part is not compulsory that is in parentheses. It may be there, it may not be there. It will still work fine. Point. I don't know you. Else. Point. I know you. Do you understand, sir?
Yes.
So this and this, they will do the same thing. So the exclamation mark is for other data types, but for boolean, it's not. I not say. I want to look at the or or. Or allows us to let me put it this way. For or, the condition is true if one of them is true. I can't remember. The overall condition is true if one of them is true. if you're dealing with let's say I'm hungry and I give someone money to get food for me. I can tell the person buy rice or beans. Meaning that if you can't find rice, please buy beans. Or means just look for one of them. I only need one of them to be so. And if both of them are so good for me, it will still do it. The person will still buy me food. Do you understand, sir?
Yes.
Okay, sir. So let's look at this. So let's look at this. A is equal to 2, B equals to 5. The condition says if if A equals to this part is 2, even though this part is false. But because one of them is 2, it's going to print hello.
Hello.
That is for all. Also, if this were to be false, but this were to be so, it will still print hello. The only case it will not print hello is if both of them are false. Do you understand, sir?
Yes.
Now, remember I said something the other time that whatever we have here end up being converted to either true or false. That if it is true, then it's going to do this part. If it is false, then it's going to do this part. Now, let's see how Python will convert this part to either true or false. What Python will do is this. It's going to ask itself, is A equals to 2? That is false. Is B equals to 10? That is false. Because both of them are false, the result will be false. Now we look at this something called truth table now. In fact, let's look at it now. I'll get a file to do that. I'll call it truth table. Here is our truth table. When we are dealing with or, if we have 2 or 2, the result is 2. If we have 2 or false, the result is 2. If you have false or true, the result is 2. If you have false or false, the result is false. This is the truth table for all. 2 or 2, the result is 2. 2 or false, the result is 2. False or true, the result is 2. False or false, the result is false. How does it affect our code? How does it apply to our code? Here is it. Is A equals to 2? That is false. Is B equals to 10? That is false. False or false? False or false is false. That means everything here, Python will see it as false. And because it is false, it's going to print go away. Do you understand, sir? So this is the truth table for all. Now, if you have longer expressions, let's add a new one. Now, this is how Python will handle it. Is A equals to 2? That is false. Is B equals to 10? That is false. Is C equals to 4? That is 2. So it will now start from beginning. False or false. False or false. According to our truth table, false or false is false, meaning that these two will combine together to turn to false. Then it now ask again, false or true. False or true is true. This. False or true is true. So meaning that these two will combine together to turn to true. So the final result is true. That means it will print hello. Do you get it, sir? Let's go to hand. Now, if I say that if I when I use and with something, that means I need the two of them to be present. Get me this and that. Or means either this or that. And means this and that. Like it was the other one must be part of it. That is for and. Or it all creates a scenario of alternative, an alternate solution. Like this or that. I need one. I only need one of them. And means I need the two of them together, not just one of them. So when we are dealing with and, before the condition can be seen as true, both conditions must be met. Before it can be true, both of them must be true. If one of them is true and the other is false, it will see everything as false. So let's look at how we can use and here. A equals to A equals 7 and B equals 2. Now, although A is 7, this is 2, but B is not 2. So this is false. So it's going to go away. That is for and. So let's look at the truth table for hand. For hand, 2 and 2 is 2. 2 and first is first. First and 2 is first. First and first is first. So this is the table for hand. So if you have something like this, so this is 2, this is 2, this is 2. So it's going to be 2 and 2 and 2. So it will start from this 2 and 2, that is 2. So these two will combine together to become 2. Then 2 and 2 again, this is 2. These two will combine together to become 2. So the final result is 2. It's a point L. But let's assume this is, let's say, 1. This becomes, is A equals to 7, that is 2. Is B equals to 1, that is 2. And the last one is false. Yes. So it's going to say 2 and 2. 2 and 2 combines together to become 2. But 2 and first, from our truth table, 2 and first is first. So the final result is first, and we'll see go away. Do you get it, sir?
Yes.
Do you have any questions, sir?
No.
Okay, sir. So let's now combine both of them together, and or. You may combine them together. So you can say in fact, let's first do it this way, then we'll change it a bit. A equals 7, that is 2. B equals to 1, that is 2. C equals to 1, that is false. So 2 and 2. 2 and 2 is 2. Then 2 of first. 2 of first is 2. So the final result is 2. It will print hello. Do you get it, sir?
Yes.
Okay, sir. But then look at what we're about to do. I'll change this to or and I'll change this to and we're going to see how this will affect our results. I want to quickly explain something here. Let's do this. Is A equals to 7? That is 2. Is B equals to 1? That is 2. Is C equals to 1? That is false. Now, before now, what we've been doing is that we'll first combine these two together. Okay? Then, whatever result it gives, we'll now combine it with this. That is, if that been like this, 2 or 2, that is 2. Then we now say 2 and false. Then the final result will be false because 2 and false is false. Do you understand, sir?
Yes.
But then there's what we call, should I call it order of hierarchy now? We have board mass. We have board mass. The same thing also in this case. We have something like board mass. That is what comes first. The first thing is parenthesis like this. It comes first. After that, we have the not. After that, we have the and after that, we have the or. In this order, parenthesis. We look at all of them. Not, and, or. So here is the order of hierarchy. Now, if you have two or two and first, because and takes precedence over or, we first consider these two. Do you get it, sir?
Yes.
So first combine these two together. Two and first. Two and first is first. We will now combine the results with this one. Two and first is two. So if you run this part now, it's going to display hello. Meanwhile, if you did not follow that order of hierarchy, we would have thought that it will display go away. So when we run this, we see hello. That's the reason for this error here. Let's look at situations that includes this exclamation mark. Now let's now assume that we put this in a parenthesis, this first part. Then this will turn to something like this. Is A equals to 7? That is 2. Is B equals to 1? That is 2. Is C equals to 1? That is first. So it will first treat this.
That's true.
That is 2. Then 2 and first, that is first. So the final result will be go away. Do you get it, sir?
Yes.
Now let's look at situations that has this note also. We can say I'm looking at one situation that may. Okay, let's negate this part. I just do it like this. Oh. That's like this. We are negating whatever this gives us. We are turning it upside down. So, not is A equals to 7? That is 2. Is B equals to 1? That is 2. Is C equals to 1? That is first. So 2 or 2. 2 or 2 is 2. Not 2. Not 2 is first. Then that will now be combined with this first and first. First. So the final result now will be first, and we're going to see go away. So this is what logic is about.
So what do you use to remember this hierarchy?
Okay, this is it. I see this bracket. It looks like that of board mass. Bracket first. Whether board mass, whether in this case, bracket comes first. Now about this and or, let's come to the truth table. What I'm about to explain now, I think it will also make this one even easier to remember. For or, see it as plus. For and, see it as multiplication. Let's first look at this and part. If 1 is 2, let's assume 1 is 2 and 0 is first. Computer, it takes 1 as 2 and 0 as first. So 2 and first becomes 1 times 1. And 1 times 1 is what? 1. So 2 and 2, that is 2. This part becomes 1 times 0. 1 times 0 is 0. So that's right first. This is 0 times 1. That's 0. And this is 0 times 0. That's 0.
So, oh,
positive. So this becomes 1 plus 1. Now, since we only want to get either 1 or 0, we will say this is 1. 1 plus 0. 1 plus 0 is 1. 0 plus 1. 0 plus 1 is 1. 0 plus 0. 0 plus 0 is 0. Do you get it, sir?
Yes.
So now, with that now, it will be easier to remember using BODMAS. In BODMAS, multiplication comes before addition.
Yes.
So the AND comes before the OR.
Okay, so it's only not that remains.
Yes, sir. So that's the other hierarchy. Brackets, nuts, and OR. Any questions, sir?
Yeah, so it's only not that we don't have any clue of how to know if it comes before and or before bracket. Yes, I know that brackets now first because of BODMAS. So not should be the next to, just imagine that it's the next to brackets.
Okay, yes.
Not okay, that's fine.
Alright, sir. So, this is the truth table and the logic. Let's look at this. Let's play with this a bit. I want to tell the user to enter the name, enter your username and your password to register. So the user will enter the username and password to register. Now, I will now tell that same user to log in with it. You know, if the user is logging in, the username and the password must be the same as the one used for registration. If they are not the same, I will tell the user incorrect. But if they are the same, I will tell the user log in successfully. Let's play with that. So I can say username. I can get a variable called username, and I will tell the user enter your username. Let's start with this. Let's first print something. Print. Welcome to my page. Welcome to my page. It is time for registration. So the user will register. Enter your username. The user will register with username. Enter your password. So, print registration successful. So let's that same user now. Let the user log in. If you want to log in, okay, let's say print. It is time to log in. Time to log in. Let's get this username now. We can say login username. The reason I don't want to call it username again is because if I call it username, it will override this. Do you get it, sir?
Yes.
So that's why I want to save it in another variable. Impute. Login password. So now I want to be sure that the username that I use for registration is the same as the one used for login, and the one for the password also, both of them are the same. So you're going to say if username is the same as login username and password is the same as login password, then print you're welcome to your dashboard. Login successful. Just a login login successful. Else, print incorrect login details. Do you get it, sir?
Yes.
Let's run it together. Enter your username. Enter your password. 1, 2, 3, 4. Registration success. It's time to log in. Enter your username. Enter your password. I will now enter incorrect password so that it can fail. Incorrect login details. So let's run it again. This time around, I want it to be correct. Login successful. Now, if this had been all, this wouldn't have worked as expected. Reason is this: for her, if my login username is the same as the one I use for registration, it would have printed login successful even if the passwords are not the same. Do you get it, sir?
Yes.
So the reason for using hand here is to ensure that both of them are correct. This is 2, and this must also be 2. So if one of them is false, I want it to fail. So if this were to be her, I'll change it to her now. Now, I only need one of them to be true. Even if the other is false, it will still print login successful. Of course, you don't want to make this mistake in real life application. Imagine you want to log into Facebook and just by getting the email alone, they tell you that it's successful. Login successful. That's the problem. So this is how it works. Do you have any questions, Sam? No. Assignments. You want to tell the user, you want to do something called CGPA calculator. But let's just grading system. School grading system. School grading system. School grading system. So this is how it's going to work. You will tell the user to enter their score, their grade. Enter your score. If the score entered by the user, if it's between this range, 70 to 100, you are going to display excellent. You will print out excellent. If the score entered is between 60 to 69, you are going to display good. If the score entered is between 50 to 59, you are going to display average. You print out average. If the score entered is between 45 to 49, you are going to display fair. If it's between 40 to 44, you are going to display poor. And finally, okay, no, not just finally. If it's between 0 to 39, you are going to display fail. Now, if it is more than 100, or less than 0, you are going to display out of range. Do you get it, sir?
Yes.
So here's what you want to do. Here's the assignments. Do you have any question on it, sir?
The question not just make it simple and say like this one we used to practice that username password. Why can we not just make it simple and say if username this one if username is, let me say, I'm just thinking if we can just limit ourselves to only if.
Okay. We've done if in the
And
last assignment.
yes, we did if, and if is simple and simple to understand. Why do we have to go to if s elif?
Okay. Reason is this. The more we build the more we build application, the more the customers demand, the more it keeps getting more and more and more. The more it keeps getting more and more and more. So this, sorry. So the more customers demand, keep getting more and more and more. So all of this if, if is based on what people want to do. Now, initially, maybe people want to do something. If was introduced. Later, people want to do one out of two things. If else was introduced. Later, people want to do one out of many things. Then, if was introduced. Do you get it? The more people want to do, the more we keep introducing these things in order to meet people's demands, so that computer will become more powerful. So in all of this, I only want to do one of them. It's either I display excellent or good or average or fair or poor or fail or out of range, based on the number the user entered. If you have to enter your grade, the user will enter user grade. Then we now do one of these based on that grade. Alright. When next are we meeting? So can we? I think okay. So you'll be free on Thursday. Okay, we can meet on Thursday. We can meet on. I think Thursday should still work. Okay, yes. I think I have it. I want to quickly check my calendar to see the time we can. Yes. We can meet on Thursday. We can meet on Thursday. Maybe 7 p.m. on Thursday.
7 p.m. Okay.
Alright, so. Thank you, sir. Have a nice day, sir.